How does operating system manages the process? What is a process? A process is a program in execution. A process can also be known as a job or task. While a program is static, normally found in secondary storage like hard disks. This can be further explained in the following example. A program getting 100 marks. You can process 1 is a student studying at home. Process 2 is a few or many students listening in class. So in order to get 100 marks, you will have to study hard and listen in class. Likewise, in order for the program to be executed, there will be processes running. This also shows that there may be many processes from one program.
What is a process control block? A process control block, or PCB, is a process descriptor. Each process have their own process control block. For example, process 1 is tagged to PCB1, while process 2 is tagged to PCB2. In each PCB, there will be the process state of the process, structuring information, process ID, program counter, CPU information, and lastly, the accounting information of the process.
This is the process state model. Once the program has been loaded, it will move to the new state. After the process has been initialized, it will move to the ready state. Once the program gets the CPU time, it will move on to the run state. However, when it needs something, it will go on to the waiting state, and then once it got what it needed, and it will go back to the ready state, and then go back to the run state. When the process is in the running state, when it gets interrupted, it will go back into the ready state. After the program has run finished, it will abort the system and exit the system. When a process is in the ready state, it needs to decide when it should run, and this decision is made by a short-term scheduler. A process scheduler schedules different processes to be assigned to the CPU based on particular scheduling algorithms. There are 6 popular process scheduling algorithms. First come, first serve. This is one of the 6 popular process scheduling algorithms. For first come, first serve, jobs or tasks are executed on first come, first serve basis. It is easy to understand and implement. However, it's poor in performance as average wait time is high. It's very fair by definition. However, it's a non-preemptive scheduling algorithm, which means that tasks cannot be interrupted once it started.
This is an example how first come first serve works. When the first man arrives, it will be processed first, and then followed by the second man, who arrives next, and the third man respectively.
Round-robin scheduling. This is similar to first come first serve scheduling, but it is preemptive process scheduling algorithm. Task which is first in the queue will get to be processed first. However, time limit is implemented. Fails to complete tasks within given time will have to queue back again. The advantage of round-robin scheduling is there is fairness since every process gets equal share of CPU. It is also simple, easy to implement, and it is also starvation-free, which will be explained later. However, the disadvantage is very important jobs have to wait in line. This is how round-robin scheduling works. The cashier has a time limit of 1 minute and she handles 3 items in 1 minute. Process 1 has 5 items and will be processed first as it is first in queue. So after 1 minute, process 1 goes back to the queue with 2 items left. Process 2 with 4 items will be processed next, but after 1 minute it goes back to rejoin the queue with 1 item left. Process 3 with 3 items will be processed next, and then it has completed and do not need to rejoin the queue.
What is starvation? Starvation is a resource management problem where 1. Process does not get the resources it needs for a long time, and 2. The resources are constantly being allocated to other processes.
So what is shortest job first? It is the task with the shortest time to be processed will be taken into the processor first, even if that task is in last in queue. While shortest runtime first is the process with the smallest amount of time remaining until completion is selected to execute. But both will result in process starvation, but it is the best approach to minimize waiting time.
This is how shortest job first scheduling works. Process 1, which represents the first man, has 10 items. Process 2, which represents the second man, has 2 items. Process 3, which represents the third man, has 5 items. With this scheduling method, process 2 will be processed first as it has 2 items, the least of all among these 3 processes, followed by process 3 and then process 1. For shortest remaining time, the cashier has a time limit of 2 minutes. Process 1 takes about 4 minutes to finish. Process 2 takes about 3 minutes to finish, while process 3 takes about 5 minutes to finish. So process 2 will be processed first as it has the shortest amount of time to be processed, followed by process 1 and then process 3.
What is preemption? Preemption is the act of temporarily interrupting a task being carried out by a computer system without requiring its cooperation and with the intention of resuming the task at a later time. This can be applied to any algorithm.
What is priority-based scheduling? It is each process is assigned a priority. Processes with higher priority is to execute first and so on. Processes with the same priority are executed on first come first served basis. But the disadvantage of this scheduling is that lower priority programs are not processed due to arrival of higher priority programs.
This is how priority-based scheduling works. In this case, process 1 arrived first, which represents the young man, has a priority of 1. Process 2 arrived second, representing a children, has a priority of 2. Process 3 arrived last, representing an elderly, has a priority of 3. Thus, process 3 will get to be processed first as it has the highest priority, followed by process 2 and then process 1.
So what is multi-level queue scheduling? Instead of a single queue, it uses several queues. Individual queues can use all the same scheduling algorithm, or they can use different algorithms. For example, first come first serve and priority based scheduling.
This is how multiple level queue scheduling works. In this case, we have two queues. Q1 belongs to the first come first serve algorithm, while Q2 belongs to the priority algorithm. So there is this process 1 and process 2 in the first come first serve queue. Normally, process 1 will be processed first and then followed by process 2, as it follows the first come first serve algorithm. However, when process 3 and 4 comes in the priority queue, process 3, which represent an elderly, will get to be processed first as it has the highest priority of 4, followed by process 4, which represent children and has a priority of 3, and process 1 and 2 will be processed next as usual.
Comparing algorithms. There are a total of 5 points for this section. There is throughput, refers to jobs run per hour or per minute. Average turnaround time, time from start to end of job. Average response time, time from submission to start of output. CPU utilization, the percentage of time the CPU is running real jobs. And lastly, average wait time, the time that processors spend in the ready queue.
What is process affinity? The operating system will use process affinity to indicate a preference for a certain type of process to run on a particular CPU whenever possible. A CPU can be dedicated to a job or sets of jobs. This can only happen if there are multiple multi-core or CPU for the different processors to run.
How does deadlock occurs? When two competing actions wait for the other to finish, and thus neither have ever done their job. Hard deadlock prevention. Prevent one of more of 3 necessary conditions for deadlock cannot occur. Mutual exclusion, hold and wait, and circular wait.
What is semaphore? Semaphore is a hardware of software tag variable. It has value to indicate the status of a common resource. Its purpose is to log the resource being used. A process which needs the resource will check the semaphore for determining the status of the resource, followed by the decision for proceeding. For binary semaphores, there are values of 0 and 1. 0 represent locked, 1 represent unlocked. Similarly, 0 can also represent unavailable, 1 represent available. There are another type of semaphore called counting semaphore. It have values that are greater than 1. In this case, we are talking about binary semaphores. This will be cache 1 and this will be cache 2. 0 represent unlocked, 1 represent locked. In this case, both are unlocked as it has a value of 0. When the first person wants to pay, he will check the status of the cache. If it's 0, the person can pay. So he will pay. When the person is paying the cache, the semaphore will change the value to 1. So when the next person wants to pay, he will check the status of the first cache. If it's 1, it's locked. He will go to another cache and check the status again. Only if it's 0, then he can pay. So now both cache has a semaphore of 1. After the first person has finished payment, the semaphore changes from 1 to 0, so that the other person next in the queue can pay.